The most important and probably best known exponential trend is Moore's Law. Most people who attend our programs or work in technology are familiar with it. You probably know its author, Gordon Moore, who co-founded Intel, now the world's largest chipmaker. In 1965, he wrote that the number of transistors per square inch on an integrated circuit has doubled every year since the integrated circuit was invented, which was in 1958. He then formulated a hypothesis that this annual doubling will continue for the next 10 years. Later, he revised it to 2 years, and Moore's Law was born. To put that in perspective, in 1949, an early computer called the ENIAC calculated pi to more than 2,000 digits in about 70 hours. Today, your modern laptop can do the same thing in less than 5 seconds. 5 million times faster than the ENIAC. Moore's Law is still progressing, and the number of transistors per circuit continues to increase. So what other exponential trends can you think of? What if I told you that Moore's Law is nowhere near the beginning of exponential growth in information technology? It's actually the stage 5, or what we call the 5th paradigm. Ray Kurzweil discovered this trend.
So you have to really study what I call the law of accelerating returns and understand the exponential nature of change when it comes to all of these information technologies. The law of accelerating returns is that the price performance and the capacity of information technology progresses in a predictable exponential manner. Your smartphone is actually billions of times more powerful per dollar than the computer I used when I went to college. It's 1 million times cheaper, it's several thousand times more powerful. That's a several billion-fold increase in price performance. That gives you some idea of what the future of these exponential technologies will be.
When people think of the future, they assume that progress will continue at the current pace. In other words, linearly. But Ray is saying technological change is exponential, not linear. In order to compare different technologies, Ray tracked computational speed per $1,000 over the entire 20th century. He began with the invention of the electromechanical computer. It used electromagnetic relays, the same type of relay Samuel Morse used to send Morse code. It was programmed by punching paper tape. Ray discovered that there have been 5 different paradigms of exponential growth, with electromechanical computers being the first. The second paradigm, relay-based computers like the Turing machine or the Enigma machine. The third one, vacuum tube-based computers. The fourth one, transistor-based computers, the very technology that brought us into space. And finally, the 5th paradigm was integrated circuits, or Moore's Law. So Moore's Law is a subset of a much broader exponential principle, Kurzweil's law of accelerating returns. What Ray did was graph all 5 paradigms together on a logarithmic plot. As you can see, they follow an exponential curve from electromagnetic computers all the way through to integrated circuits. Now we know that no technology will grow exponentially forever. Eventually it will flatten out. So what's going on here? Here's a way to better visualize Ray's law of accelerating returns. A single growth pattern looks like an S-curve. In the beginning it's slow because exponential trends start out slowly. There's a point in the curve we call disappointment. That's when you want technology to be better than it actually is. So what happens is you're totally dismissing it, right? Next, technology enters a period of rapid or exponential growth. This is when things get really interesting. I was in the audience when Steve Jobs introduced the iPhone to the world. And the person next to me pulls out his flip phone and literally says, "Crap." This is the moment you cross the line. This is the point when everything changes. When you come into a world where there's chaos and amazement, this is where you can't even keep up with the change you're seeing. Then there's a point when the technology reaches its limits and you reach the plateau. Moore's Law has been true for 50 years. But in 2015, the Intel CEO said that the number of transistors per square inch is doubling at a rate that is now closer to 2.5 years. Soon, the distance between transistors will be 6 to 7 nanometers. And at 2 to 3 nanometers, physics just don't work anymore. Electrons will jump between the transistors. So at that point, Moore's Law will flatten out. Now here's the cool part. This is how Ray Kurzweil's law of accelerating returns looks when you stack one paradigm on top of each other. No technology develops in isolation. Each new technology replaces the old technology. It picks up where the last one left off. And what we get is this graph that looks like nested S-curves. When you put them together like this, they make their own exponential curve.
If you look at the history of computation or communication or any of these information technologies, that exponential progression goes through war and peace, through boom times and recessions. It went through the Great Depression. People say, well, it must have slowed down during the recent recession, but that's not the case. So it goes through thick and thin. Nothing really seems to stop it. If it were just a few people, it would be subject to the vagaries of what people do. But since it's millions of people, it's an evolutionary process and has these predictable aspects to it.
So it seems the only constant is change, and the rate of change itself is accelerating. What will be the next paradigm that will replace Moore's law and integrated circuits? How about 3D printed self-organizing molecular circuits or quantum or biocomputing? What if one day a powerful computer could fit inside a single blood cell and we could put that blood cell back into your bloodstream? What would this mean for your life? Would it redefine who we are as human beings? Knowing what you know now about the law of accelerating returns, do you think it's possible, probable, or maybe truly right around the corner?